In this video, we'll write the balanced net ionic equation for Hg NO3 plus Na3PO4. This is mercury 2 nitrate plus sodium phosphate. So when we do these net ionic equations, the first thing we need to do is balance the molecular equation. This is the molecular equation. I can see that I have 3 mercury atoms here and just 1 here. So I'm going to put a 3 in front of the mercury 2 nitrate. Now I have 3 times 2, 6 nitrate ions. So I'm going to put a 6 over here in front of the sodium nitrate. 6 sodium atoms, could put a 2 here, balances the sodiums. Now I have 2 phosphates, but that's okay. I have 2 phosphates here. So this is the balanced molecular equation. Next, we need to write the state for each substance. If you know your solubility rules, nitrates are very soluble. Put a little AQ for aqueous. This will dissolve, dissociate into its ions. Compounds with sodium are also very soluble, AQ, aqueous for that. And then we have this mercury phosphate. In general, phosphates are insoluble, except things like sodium or potassium phosphate. This is going to be insoluble. It won't dissolve. Since it doesn't dissolve, it's a solid. These two substances react. They create this solid. This is a precipitate. And this precipitate, it falls to the bottom of the test tube. Sodium compounds and nitrate compounds, those are soluble, put an AQ there. So we form this precipitate here from this reaction. Now we can split the strong electrolytes into their ions for the complete ionic equation. So mercury, we don't know its charge because it's a transition metal, but we do know the whole nitrate. That's 1 minus. We have 2 of them. So 2 minus here, this has to be 2 plus. So we have 3 mercury 2 ions, and I won't write the states now. Let's do that later. Plus 2 of the nitrate ions. And then sodium, that is in group 1 on the periodic table. That's 1 plus. And the whole phosphate ion, 3 minus. Good one to remember. So 2 times 3, that gives us 6 sodium ions. And then we have 2 of these phosphate ions here. PO4, 3 minus. So these are the reactants in our net ionic equation. For the products, we don't split solids apart. We have this precipitate here. It's a solid. We don't split it apart. Just Hg3, PO4, 2. And then we said sodium's positive, the nitrate ion negative, 6 sodium ions, Na plus, just like the reactants. And then 6 of these nitrate ions, also like the reactants. So this is the complete ionic equation. Now we can cross out these spectator ions. They're on both sides of the complete ionic equation. We have our reactants here and our products here. So when I look at this, I can see I've made a mistake because I see 2 nitrate ions here and 6 here. And if I come back 3 times 2, I should have 6 nitrate ions. So I'm going to change that. So I've caught this error here right now, and I'd also be able to catch it at the end, and I'll show you how. So I have 6 nitrates here. These are spectator ions. We'll cross these out. I can see I have 6 sodium ions here in the reactants and here in the products. So those are spectator ions, and we can cross those out. But what's left, that's the net ionic equation for HgNO3 plus Na3PO4. I'll clean it up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for mercury 2 nitrate plus sodium phosphate. I have the charge balanced. I have 3 times 2 plus, that's 6 plus. 2 times 3 minus is 6 minus. So 6 plus 6 minus, net charge is 0. Over here, the net charge is 0. If I hadn't corrected that error earlier, this would not work out. You can also see the atoms, they're balanced too. This is Dr. V, and thanks for watching.